Hello BSRT3 students. Welcome back to our virtual classroom in RT315. This is radiation protection. So as of the moment, I have done with a graded recitation via phone calls through Facebook Messenger. So it's nice to know that even though we're in a virtual setup, so most of you are reading or learning, watching my videos. So it means to say that even though we are in the midst of the pandemic, so education is still there. So congratulations for reaching this far, because this is the final module for the midterm period. After this module, I will now administer the midterm examinations, and I hope you will study. Okay, so this morning we will discuss the radiation detection and measurement. So based on, I can't remember what module, I guess that was module 4. So we have discussed the different fundamental principles of radiation protection, diba? So we discussed the principle of justification, the optimization, and of course the principle of dose limitation. And as far as the module is concerned, so we have give you the dose limitation for public as well as for occupational exposure. So we said that is limited to 50 millisievert per year, average of 5 years. But the question is, diba, sir, paano po ba natin malalaman, or how are we going to know that the dose has already been reached or exceeded? Okay, so may instrument po ba? Yes, there are instruments, and that is our discussion for this morning. So instruments are designed either to detect radiation or to measure radiation, or if your desire is to detect and to measure radiation at the same time, so that is also possible. Those designed for detection generally operate in pulse mode or in rate modes, used to indicate the presence of radiation. So in pulse mode, the instrument response is measured in terms of milliröntgen per hour or Röntgen per hour. So those designed to measure the intensity of radiation usually operate in integrate mode. So when we say integrate mode, they accumulate the radiation first and then respond with a total exposure in terms of milliröntgen or Röntgen. So such application is called dosimetry, and the measuring devices or the detecting devices are called dosimeters. Okay? So before we move forward, I have tweaked your module. So let's consider some of the major uses of devices. So here we have monitoring. We also have here for survey. Okay. We have here, yes, also this is for measurement of the presence of radionuclides. So personnel monitoring. Personnel monitoring. So this is also for imaging, mamukod tangi. And this is for personnel monitoring. So we can say that the instruments are used or have different uses. So pwede siyang pang-occupational, di ba? Personnel monitoring, ayun, personnel monitoring, hain pa. Okay, personnel monitoring. And pwede siyang for public. So mayroong survey for fields. Okay, so the amount of radioactive substance. Okay, so pwede gihapon in terms of imaging. Okay, so iba-iba pala yung function. So before I give you the different devices or instruments. So ito siya, photographic emulsion. We have that is used, or the characteristic usually is limited range, sensitive to radiation, sana all sensitive. Energy dependent, which means depende sa energy ng radiation. Halimbawa, na-differentiate niya yung sunlight, okay, so gamma, so yun. Depende sa radiation na paggagamitan. Kasi some, hindi na gagamit ng film, ng photographic emulsion kasi masyado nang mataas yung radiation, hindi na madedetect. Ganun. Ionization chamber, this is used or wide range, accurate, portable, and di siya pwedeng pang personal monitoring. Gamit niya is survey for fields greater than 1 milliröntgen per hour. So, pag-detect ng area. We also have proportional counter. This is laboratory instrument, okay, accurate, sensitive to radiation, and this is used to measure the presence of radiopharmaceutical, okay. Next, we have the Geiger-Müller counter, limited to less than 100 milliröntgen per hour. Ani klaron ta kadali yan. This is limited to 100 milliröntgen per hour, portable, personal monitoring, ayun. And this is stationary monitoring. Next, we have TLD or the Thermoluminescence Dosimeter, wide range, accurate, and this is sensitive. And this is used for personal monitoring. Okay. So, another, we have scintillation detector. Okay, limited range, very sensitive, stationary or portable, photon spectroscopy. Yun, may term na spectroscope, ano. And then, this is used for imaging. So, meaning, detector siya for a certain type of, like for example, CT scan, yun. And the last but definitely not the least, this is the Optically-Stimulated Luminescence Dosimeter. So, wide range, accurate, sensitive, and then this is used for personal monitoring. So, ayun. So, alam na natin na there are instruments that are used for occupational exposure. Yun yung mga personal monitoring. And, of course, those are designed for public as well as for equipment, for imaging, yun. Okay? Okay, sige. Let's have our first instrument. Or, no. Teka muna. Nagdali ako, ano. So, based on the FDA, so isang ating mga tinatawag na one of the guidelines of the Department of Health. So, kailangan may mga basis tayo. Why do we have or why the radiology facilities are or should have these types of instrument. So, if you can read 6.2, it says here that the owner or the licensee shall provide personal dose monitor, o specific siya dito, TLD or OSL, TLD or Thermoluminescence Dosimeter, or pwede gihapon mag-OSL, Optically Stimulated Luminescence Dosimeter, to all radiation workers in the facility. Okay, radiation workers ha, it doesn't exempt the chief radiologic technologist. Okay, so bakay chief radtech sometimes nala nag-x-ray kay more administrative na siya. But take note that the chief radiologic technologist is a licensed radiologic technologist. So he is entitled to have a TLD or OSL, personnel monitoring device. So sir, what about the clerk or the secretary that is not registered radiologic technologist? Okay, so is she or he qualified to have a personal monitoring device? The answer is no. Especially if, syempre, specific naman talaga class that radiologic technologist employed in the hospital, especially in the radiology department, is expected to work in the field of or radiological procedures. So nagkakandak ng X-ray kasi nga RRT. Oo. So not unless i-deploy siya sa ibang offices. But for clerks and mga secretaries who are not registered radiologic technologist, siguro kung nag-X-ray tapos dire siya RRT, well, isa yung pananagutan kasi kailangan sa guidelines ng DOH, kailangan registered radiologic technologist ang mag-handle ng procedure. Pag dire siya RRT, so meaning secretary siya or aide, ano? So aide, secretary or clerk, so they are not entitled or di naman necessary na they will be provided with personnel monitoring devices such as OSL or TLD. Kasi they are expected not to carry out radiological works. Yung clerks, aide, and secretaries ng radiology department are so confined to entertain patients. Okay, so more of to see the request, to check if the request is complete. Yun, mga diri siya nag-handle ng x-ray, ganun. Recording, okay, filing, di ba? So, not necessary to handle x-ray procedures, ganun. Parang natagalan ako kaka-explain na, no? So, in other words, all radiologic technologists who are PRC holders that carry out radiological works are only those who are entitled to have personnel monitoring devices. If the chief radiologic technologist is not working kasi nga more of administrative it kanya function, of course, he is also entitled for a personnel monitoring device. Kay RadTech siya. Okay? Ganon lang yon. Sige. Yon. So the earliest radiation detection device was the photographic emulsion. This is more commonly known as film badge. So I have shown you an example sa ating school. Actually, ginabrihan pa ni Keith because he wanted to see what's inside. So, okay, nakita natin nga film man na adto, no, parang dental film. So, this is the oldest radiation detection device, pero sa gadidiha book still the primary means, but sa DOH guidelines nag-specify na madiri na kita magamit dapat in film badge. We are to use TLD or OSL. But there are institution talaga kasi class TLD and OSL are quite expensive, so they prefer to use film badge. But kung ako nalaliwat kasi this is ano lang kasi to hindi siya economic kasi once the film has been processed, alam nyo naman, na-develop na fixed na ang image, so the supplier will use another film for that purpose. Whereas TLD and OSL are reusable. Yan, sige, di-discuss natin later. So, ayun. Next, we have gas field detectors. So, napansin natin kanina, gas field detectors. So, for example, ionization chamber. Okay, so more of survey for fields. Ito, proportional counter, assay or measurement of radiopharmaceutical. Ito, Geiger-Müller counter. Ito, pwede siya personal monitoring device or stationary monitoring. Okay, so gas field detectors. So, the following three types of gas field detectors are used. So, we have ito, ionization chamber, we have proportional counters, and of course, the Geiger-Müller detectors. So, these three, although they are different in response characteristics, each is based on the same principle of operation. Kaya nga, they are categorized under gas field detectors. So, yung mga typical example nito, for example, if you will be working on a high radiation areas such as sa mga let's say for example meron pa nagpre-prepare pa kamuhin high radiation therapy, may may radium pa, okay, so may cobalt, so pwede itong gamiton dito. Pero sa mga X-ray department, I guess diri na siya ganun ka magiging diri siya ganun ka advisable to use this gas field detectors. Kaya nga makikita mo most of mga radiology facilities, okay, so waray good kita mga gas field detectors. We are so limited to TLD, OSL, or kung may pa man nagamit film badge, ganun lang sa personal monitoring. So, ano tiya principle of operation? So, as radiation passes through the instrument or through gas, kasi gas field nga so we are to assume that the instrument is filled with gas. Okay? So, it ionizes atoms in its path. So, for example, ito sa ating illustration, there is the photon or the radiation. So, there is an interaction with the instrument. So, ito, nag-ionize siya ng gas which is inside the device. So, the electrons released in ionization are detected as signal proportional to radiation intensity. Do I have to explain? So, kung anong energy photon, ganon ionization rate. Okay? So, this ionization of gas is the basis of these gas field radiation detectors. Okay, so what else? So along its central axis of the cylinder, pansinin nyo to. So ito, hinighlight natin. To, yan, parang stick. So is a rigid wire called the central electrode. Tawag nga dito, anode wire. Okay, so anode kasi, di ba, the electrons are negatively charged, of course, mas maa-attract siya inside that positive center, di ba? Which is, kasi nga anode, positive. So, if a voltage difference occurs between the central electrode and the wall, so electrons will be liberated in the chamber. What happened? Or ano't masunod nga matatabo? These electrons form electric signal as pulse of electrons or a continuous current. And this electric signal is amplified, yon. So, ionization, and then it is attracted in the central electrode. And then, the electrical signal or pulse in a form of continuous current is amplified, and then this is measured. So, again, the intensity is proportional to radiation intensity that caused the ionization. So, in general, if we use a larger chamber, the more gas molecules are available for ionization, and therefore, the more sensitive the instrument. So, a high sensitivity means that an instrument can detect very low radiation intensities. So, kung yun, mapansin niyo, as per our reference, sabi nga dito, if we are to measure low level of radiation, such as in radiography, so we are expected to use mga dagko nga chamber. Dire pwede ang mga digtoy-digtoy laan, pwede isulod a borsa. So by the way, kung makikita niyo kasi may mga examples dito, balikan ta. So ito, may mga tinatawag, usually pag makita ka mong radtech nga nagamit sini, danay tatawag ininira nga pen dosimeter, pen. It's like ball pen kasi iti appearance. Pen dosimeter, or it iba, ginagamit niya at tinatawag ito niya nga pocket dosimeter. Kasi pwede ito isulod la borsa, yon. Not unlike iton OSL or TLD nga ipapakot mo siya sa collar, di ba? So ini pwede mo isulod la borsa, or it ibaliwat tinatawag ini niya nga ring badge. In a form of sing-sing. So these are examples of gas field detectors. So do not forget pocket dosimeter, pen dosimeter, ring badge. So these are forms of gas field detectors. So again, among the gas field detectors sa yula, it pwede magamit nga personal monitoring. Ito lang siya, si Geiger-Müller counter. The rest, this is for survey, analysis, or to measure the level of the radioactive substance that is present in your department. Which, in other words, these devices are used for high levels of radiation kasi nga, if we are going to measure low levels of radiation, kailangan dako ito nga instrument. Okay? Now, let's come to scintillation detectors. So, scintillation detectors, as we mentioned earlier, this is not used either for personal monitoring nor for the survey fields. So, this is used as detectors in diagnostic imaging, in the gamma camera, such as in nuclear medicine, and in some detector arrays in CT scanners. So, consider natin, this is the gantry of your CT scan. So, ito. Gantry. So, inside the gantry, adadidan aton X-ray tube. Tapos, may mga detectors. Ito nga, To, may mga detectors nga naka-align. So, each detector is composed of, or the detector array, kasi sequential yan eh, sequence. So, each array is in the form of scintillation crystal. Ayun, so ganun ka-complicated pala. Okay, so again ha, scintillation detectors are not used either for personal monitoring or for survey for fields, but this is used as detector for radiation. Okay, so for example, in nuclear medicine and in gamma camera. Therefore, this is used for imaging. Yan. So the scintillation detector process occurs when a flash of light is emitted from the absorption of ionizing radiation. Okay? So there is again absorption of or emission of light. Light is emitted from the absorption of ionizing radiation. The amount of light emitted is proportional to the amount of energy absorbed by the material. Okay? So kung kanina sa gas field detector, the amount of ionization is equivalent to the energy of the radiation. Dili gihapon, the amount of light that will be emitted will be equivalent to the intensity of radiation. So only those materials with particular crystalline structures will scintillate. So class, magkaiba thermoluminescence dosimeter, magkaiba iton at sa cassette gani, sa intensifying screen, di ba? There is emission of visible light. So magkaiba siya. Kasi dito we use phosphor. Here, we use crystal. Okay, so nano ito nga crystal? Crystal ni Madam Auring. So, at the atomic level, the process involves the rearrangement of valence electrons into traps. The return of electron into its normal position is immediate during the scintillation process. So the return of valence electron causes a flash of light to be emitted. If you can still remember our discussion on excitation, so ganon iya emission of light. Diba? So when there is a radiation or a stimulus, so this valence electron will be raised to a higher energy level. Diba tawag naton dadto last time is ano to? Diba we have terms before, we said there is the conduction band, diba imaginary, but we have the valence band. So if the electron received a stimulus either through radiation, so it will be raised to a higher energy level. Now makadto na siya conduction band. And eventually mabalik siya into its normal position. So, mabalik siya sa kanya valence band. So, when it is raised to a higher energy level and then go back to its original position, so there is emission of light. So, what I'm trying to say is the emission of light in a scintillation detector is similar to that of excitation. Same process lang, class. So, light produced during scintillation is emitted isotopically, meaning with equal intensity in all directions. So, when it is used as a radiation detector, scintillation crystals are enclosed in an aluminum that has a polished inner surface in contact with the crystal. This allows the light to be flashed or light flash to be reflected internally to the face of the crystal called the window. Okay, so kung mapansin niyo, this is a typical example of a scintillation detector. So here, we have this portion. Okay, so nakabalot siya sa aluminum. Okay, so to direct our light pakadi sulod. So if this is now the aluminum, ayun no, aluminum foil, okay, nag-i-emit siya ng light, so which is only directed towards there. Ayaw na pag-focus na iba, ayaw na paghanapin iba. So ganon. Okay, de-designate an iya direction ng light towards a certain portion called the window. Window of the photomultiplier tube. So the crystal needs to be sealed Because this is hygroscopic, meaning they absorb, okay, nakulang, moisture. Oo, pasensya na. Kay deridanay compatible ito na halaptop nga slide. Pag ika din na cellphone, nakukulangan danay ko na na-check. Pasensya na class ha. So, hygroscopic, meaning they absorb moisture. Okay? So, again, it is sealed with aluminum para the emission of light is only toward a special portion called window of the photomultiplier tube. Yon. The photomultiplier tube converts light flashes from the scintillation or scintillator into electric pulses. So the photomultiplier tube is a electron vacuum tube that contains the following elements. So we have the glass envelope, the window of the tube, sabi nga natin kanina, from the scintillator, ididirect ng light papunta sa window lang of the photomultiplier tube, the optical coupling, and the photocathode. So by the way, class, photomultiplier tube, kung nabasa natin kanina sa table, this is also called spectroscope. Yan. I hope nababasa niyo akon kasurat. So basically, ini nga portion, and may aluminum, that's the scintillator. Siya yung nag-i-emit ng light. So the light that is produced are focused to one portion, the window. Yun. So, ito, glass envelope, may dangayan discussion. So, the glass envelope provides structural support for the internal elements and maintains the vacuum inside the tube. Parang sa sa X-ray tube, di ba? May dagihapon kita tinatawag na glass envelope. So, ganun gihap iya function. How about the window? The window of the tube is the portion of the glass envelope that is coupled to the scintillator to be transmitted to the interior of the tube with minimum loss. So, sa window, siya yung taga-receive, ayun, ng light from the scintillator. What else? So, as light passes from the crystal into the tube, it hits a metal coating called a photocathode. Back tayo ng slide. So, ito. Photocathode. This is important portion ng photomultiplier tube. So, anong function? So, which consists of cesium, antimony, and bismuth compounds. So, the photocathodes emit electrons when illuminated. Such the process is called photoemission. So, the number of electrons emitted from the photocathode is directly proportional to the intensity of the incident light. Parang medyo complicated kung mapansin nyo. Kasi radiation, interact with a scintillator. So, the radiation, naging visible light. And then, from light, i-convert siya into electrons. Kung ma-review natin, we have the term thermionic emission. But the thermionic emission, siya class? This is emission of electrons by application of heat. Pero dito sa photoemission, emission of electrons by application of light. Again, not all elements can do that. Diba? Kaya nga dito, may mga materials tayo. Cesium, antimony, and bismuth compounds. So, these are the components of photocathode. So, from the window, from the scintillator, nag-emit siya ng light. So, this light will only be focused to one portion of the photomultiplier tube called the window. So, from the window, the light will pass from, and it will hit a metal coating called a photocathode. And from the photocathode, the light will be converted into electrons. So, the photoelectrons now are then accelerated through different series of plate-like elements called dinodes. So, the electron pulse is amplified by secondary electron emission. Okay, so, mapapansin nyo dito, medyo mapaspas lang siya, no? So, ito, radiation, from radiation, naging electron. So, from electron, from radiation, naging light. Sorry. So from light, this is the photocathode, the light will be converted into the electron. So from 1 electron, magiging 2. From 2, magiging 4, 8, 16, 32, 64. Ganon. So, kaya nga tawag sa kanya is photomultiplier tube. Tron ko ha. So, again, radiation, magiging light. Light, ifo-focus sa window. So, after that, it will hit a portion called the photocathode. So, from light, magiging electron siya. So, the electron will be emitted. So, from 1 electron, ito isang dynode. It will pass to another dynode. So, from 1, magiging 2. From 2, pasa sa isa pang dynode, magiging 4. 4, magiging 8. 8, magiging 16, 32, 64. So, yun. Kaya nga, photo multiplier tube or this is, spectroscope. Yun. Photomultiplier tube. Kaya, from 1 electron, magiging 2, 2, magiging 4, 4, magiging 8, 8, 16, 32, so on, so on. So, the last element is called, or the last collecting electrode is called a collector. Yan. And which absorbs the electron pulse and conducts it to a preamplifier. So, the preamplifier provides initial stage of pulse amplification. So, therefore, mami-measure natin yung intensity in the form of the number of electrons na marireceive ni collector. So, the overall result of scintillation detection is that a single photon interaction produces a burst of light, which produces a photoelectron emission, and then which is amplified to a large electron pulse. Yun. So, the size of the electron pulse is proportional to the electron absorbed by the crystal from the incident photon. Ang saya niya, no? But again, this is used as detector lang siya, class ha, hindi siya in a form of a measuring device or for personal monitoring. Yun, so that's the process ha, from radiation, so naging light, from light, ifo-focus siya sa to the window, and then it will hit the photocathode. From the photocathode, the light will become electron. It will be amplified through series of dynodes. It will be collected, tapos it will be measured. So, scintillation detectors are sensitive devices for detecting X-rays and gamma rays. The detector is sensitive to radiation intensities as low as single photon interaction. As a result, scintillation detectors are useful as portable radiation detectors to monitor the presence of low contamination and low levels of radiation. Okay, so next, we have Thermoluminescence Dosimeter. Thermo, di ba? Therm meaning heat. Okay, luminescence, emission of light. And then dosimetry, di ba? This is the process of measuring and detecting radiation. Okay, so thermoluminescence occurs when materials are heated, kaya nga therm, and emit visible light. So, many materials, including some body tissues, exhibit the property of radiation-induced thermoluminescence. Materials for TLD are generally inorganic crystals. Crystals din. Yung, di ba kanina sa scintillation detector, we are using sodium iodide. Parang hindi ko ata na-mention. So, here, sa scintillation, we are using sodium iodide crystals. And in here, ano't gagamitan natin yung crystal for TLD? So, lithium fluoride is the most widely used TLD material. It has an atomic number of 8.2 that has a property similar to soft tissue, meaning sensitive siya. So, it can measure low levels of radiation. Thus, lithium fluoride is considered a tissue equivalent dosimeter. So, lithium fluoride can measure as low as 10 millirad, or that is equivalent to 0.1 gray, and as high as 10 rad, or that is equivalent to 100 milligray, with accuracy better than 5% compared to film badge. Oh. So that is why you can now tell why the FDA or the Food and Drug Administration from the Department of Health prefer to use TLD compared with film batch, because this is more sensitive. Again, sabi nga dito, this is a tissue equivalent material. So how is, or what's the principle of operation with the use of TLD? Of course, TLD badge siya gihapon. Okay, so ipapakot sa may collar nga part. Then, the TLD is reusable. Okay, so kasi class, gano'n yan, may monitoring period tayo na tinatawag. For example, like us, that's quarterly, meaning 3 months yung monitoring period. So, we are going to ask for a supplier. For example, kami sa University of Eastern Philippines, our supplier is the Philippine Nuclear Research Institute. So, doon kami kumukuha ng OSL. So, after 3 months, we are going to send, I guess now 2 months na lang, okay? After 2 months, we are to send the device to PNRI. That is for, for reading. So, sila na ang magbibigay ng result. Kasi wala tayo ditong instrument that can say kung ilan or the amount of radiation that is received by a radiologic technologist. So, after iton, pag ma-process na siya, kumbaga, kasi di pa natin aram kung ano't pag-measure So, kung ma-measure na, yun, yung lithium fluoride that is contained in the instrument, pwede pa siyang gamiton atro. Kaya sabi nga dito, this is reusable. So, when irradiated, the energy absorbed by the TLD remains stored until released as a visible light by heat analysis. So, the heating restores the crystal to its original condition and makes it ready for another exposure. Okay, so do not be confused ha. The radiation gintitirok sa film sa TLD. We are not storing the radiation. Kumbaga, the interaction na nahimnabo for a certain period, yun yung nami-measure. Okay? Diri naton gintatago di daan radiation. So, the way radiation interacted with lithium fluoride, mao ito ang magiging amount of radiation that is or that was received by radiologic technologists. So, it's not the radiation, but it is the interaction to the lithium fluoride. So, after irradiation, sabi ko nga, in a monitoring period, let's say 2 months, the TLD phosphor will be sent, the Thermoluminescence Dosimetry will be sent to your supplier, tapos saranat dito at magme-measure. So, ganito yung ginagawa nila because ako personally, wala pa akong idea kung how to measure or read the substance. Baka naman UEP, pwede naman kami dito mag-field trip one of these days, para makita natin what's supposedly the process of reading. Diba that was our actual plan? Kaya lang nagka-pandemic. So we want to visit sana the PNRI and the FDA in Manila, but sad to say, yun, we are here. Wala talaga lahat ng ating mga plano because of this COVID-19. Okay, so the TLD phosphor is placed on a special dish called the planchette. Parang siya, platito. So the lithium fluoride, the crystal will be placed here. So it will be analyzed in the analyzer ito. So pagkaaram ko, ipapasok siya dito. Then the temperature of the planchette is carefully controlled. Ayun. So, iduduso siya nga to, tapos the planchette will be heated. Kaya nga, thermo. Papasuon siya. Then, the output signal from the PM tube is amplified and displayed. So, technically, this is the planchette. So, it will be heated. So, once it is heated, mag-i-emit siya ng visible light. Ayan. So, this light will now be measured. Paano i-measure ang light? Okay, so, directly viewing the planchette is a photomultiplier tube. Yun naman pala. So, mayroon tayo ditong photomultiplier tube. Diba? Discuss natin kanina, may window, may photocathode. So, from light, i-convert into electron. From one electron, dadaan siya sa different dinodes. So, from one dynode, ipapasa sa isang dynode, so magiging 2 electrons, 2 magiging 4, 4 magiging 8, 8, 16, 32, so on, so forth. So, the output signal from the PM tube is amplified, yun nga, because of maagi siya sa series of dinodes, and then displayed on a meter or chart recorder. So, it will be amplified and then it will be measured. Ayun, so may radiation dose ka na receive. So again, yung crystal dito, after nag-emit na siya ng light, pwede na siya ulit magamit. Kaya this is reusable. Okay? Sige, let's come to the last instrument. This is Optically-Stimulated Luminescence Dosimeter. Siyempre, this is the last module. Kailangan nandyan yung bida-bida. Okay, so because here in the University of Eastern Philippines, we are using the Optically Stimulated Luminescence Dosimeter or OSL. I know, nakita nyo na yan. Nandun, displayed yan. Meron tayong sa X-ray room. Meron tayong sa personnel. Yon. Sige. I know may question kayo. Sige, babatanong ko ito niyan. So, with a minimum reportable dose of 1 millirad, OSL is more sensitive than TLD. Kasi nga, sabi natin kanina, per adto, 10, di ba? 10. So, reportable dose ng OSL is 1 millirad. So, more sensitive siya than TLD. OSL has a precision of plus or minus 1 millirad, which beats the TLD. Other features of OSL include reanalysis. Okay, halimbawa, medyo intriguing an imodose. Bakit naging ganun? So, pwede siya ma-reanalyze. Dito kasi sa TLD, once it is processed, nag-emit na siya ng visible light, wala na siyang reanalysis na may himo. Yun na yung dose mo. Dito daw, kaya nga I'm using daw kasi I'm not so sure kung what's the process of analyzing the data or the radiation received by the radiologic technologist. So, qualitative information about exposure conditions with dynamic range and excellent long-term stability. So, kanina sa TLD, gumagamit siya ng lithium fluoride. Sa OSL, it uses aluminum oxide. Ano yun? Napara ko. Aluminum oxide, which, okay, so irradiation of aluminum oxide stimulates some electrons into excited state. So, during processing, laser light stimulates these electrons, causing them to return to their ground with the emission of visible light. Kanina kasi sa Thermoluminescence Dosimeter, di ba, they are using, diri siya laser. Heat lang natin yung gagamit, kaya nga thermo. Here, they are using laser sa OSL to stimulate the radiation. So, after that, nag-i-emit din siya ng visible light. Just like the process ng TLD, so directly viewing the light emission is the photomultiplier tube. So, the intensity of visible light emission is proportional to the radiation received by the aluminum oxide. So, klaroon ko lahat, it's not the radiation that it's stored within the crystals. So, the interaction to the crystals by the radiation will be measured. But it's wrong to say that nandun yung radiation dire. Okay? Okay, so, I know, una, may question ka mo. How many TLDs or monitoring devices are used for department? So, yun, sa UEP, kung mapansin niyo, we are 3 radiologic technologists, but we have 4 personnel monitoring devices. We have 4 OSLs. Because, kailangan, there is a control badge. Yung tinatawag nating control badge, which is parang cumulative siya na na-receive for each RadTech. Parang confirmatory. Halimbawa ako, ganito yung dose na na-receive ko, si Camille ganito, si Rachel, ganon yung na-receive niya. So, that's the control badge will confirm na talagang Ganon yung na-receive ninyong dose. Control badge yung tawag. So, 1 control badge for every unit, for every machine sa inyong department. And then, 1 TLD, or if you are using OSL, for every working radiologic technologist sa department. So, again, waray TLD or waray personal monitoring sa aide or secretary. It's not to demote ha, teraranggo, but technically they will not be handling radiological procedures. Okay? So ano pa? If you have questions, please do not hesitate. We have different platforms. You may reach me in any mode you want. Okay, so that's all for now. So this has been your teacher, your professor, instructor, your friend, and at the same time your vlogger for this module. So good luck and God bless on your midterm examinations. So this is all for now. See you next time. Goodbye.